The REUPlus2C is an enhanced and improved replacement for the original 1764 RAM expansion unit for the C64. The REUPlus2C is designed to work with both PAL and NTSC C64s. The REUPlus2C is powered by the C64 and requires no external power supply. The REUPlus2C draws less than 100 milliamps from the C64, which is less than 1/4 of the allowed current. The REUPlus2C is register compatible with the original 1764 with the required enhancements to fully utilize the 32 megabyte SD RAM that is available. The FPGA emulates all of the original operations of the 1764 and has been tested with the Commodore 1764 RAM test program, as well as the Commodore Globe and Pound programs and several demo scene programs written for the original 1764. All tests have been successful. In addition, 2 Commodore 64 users have tested prototype versions of the REUPlus2C and have found no problems. Many thanks to those testers. In addition to 1764 compatibility, the REUPlus2C has also the ability to read and write to any location of the 32 megabyte memory by using the I/O page at DEXX. This provides a GeoRAM-like functionality, but it is intentionally not register compatible with the GeoRAM. The REUPlus2C provides complete software control for the XROM and game inputs and thus allows the SD-RAM to act as cartridge memory once loaded with the data and code desired. The control of the XROM and game inputs also allows the REUPlus2C to place the C64 in Ultimax mode. There are other enhancements that will be shown in this video and documented in the REUPlus2C manual. The REUPlus2C is the lower cost version of a pair of REU replacements. The REUPlus4C is also in development, and it is software compatible with the REUPlus2C but adds many more features. More information about the REUPlus4C will be available shortly. The REUPlus2C consists of 2 PCBs, the FPGA board and the C64 interface board. The FPGA board can be purchased on eBay for between $18 and $26 depending on the seller. The board has been used for several projects, including Grant Searle's Multicomp project. This board has an Intel EP2C5 FPGA in a 144-pin QFP package, programming connectors, and the required voltage regulators. The board is powered by the 5-volt rail from the C64, and the FPGA board 3.3-volt regulator powers all of the components on the C64 board. This design uses every available user I/O pin on the FPGA, so some components on the development board must be removed. These are the 3 LEDs, their associated resistors on the back side of the board, and 5 resistors and 1 capacitor on the back side of the board. As you can see, the connectors are mounted on the bottom of the board. There are 4 28-pin connectors that provide the 3.3 volt power and FPGA signals to the C64 interface board. There's a 2-pin connector that routes the C64 plus 5-volt power to the FPGA board. The FPGA development is done on the Quartus version 13 software that is a free download from the Intel website. It is important to use the version 13 software because later versions do not support the Cyclone 2 device on the FPGA board. The C64 interface board is a 4-layer board with 2 signal layers and ground and power layers. This increases the cost of the board but also provides the best signal integrity for the interface. The interface board provides the connector to the C64 expansion port, level shifting buffers that translate the 5-volt signals from the C64 to the 3.3 volt signals used by the FPGA. The board includes a 32 megabyte SD-RAM used as the main memory, a battery-backed real-time clock, a small 256 byte EEPROM, SD card interface. There are also headers provided for a reset switch and for an NMI switch. The FPGA board is mounted to the connectors provided. The backup battery for the real-time clock and several passive components are mounted on the underside of the PCB. The components used on the interface board are almost all surface mount components. This board can be built by hand by a well-equipped hobbyist with experience in surface mount technology. This clip demonstrates the REUPlus2C running the 1764 RAM test program. This clip demonstrates running a demo scene program that uses the REU. This clip demonstrates reading from the RTC on the C64 interface board. This clip demonstrates doing a raw read from the SD card on the C64 interface board. Thank you for watching this demonstration video of the REUPlus2C. The GitHub page for this project will be updated with the latest FPGA and PCB files by the end of February 2021. Once again, thank you.